This is the final version of my breadboard AT-Mega 328P circuit. In this circuit, there is an analog input side, which is the LDR voltage divider on the left, and a serial processing unit, which is the AT-Mega 328P itself, and a digital output side, which is the LED bar graph, which is able to read the analog input and produce the digital output that is seen here. Also, to power this circuit after the AT-Mega 328P has been programmed, a 5-volt voltage regulator is used since the AT-Mega cannot take more than 5 volts and a 9-volt battery is being used to power it. Here's a clip of the basic blink sketch working on the breadboarded AT-Mega 328P. This is what the final product was built off in the beginning. The input side of this project is essentially a voltage divider with a fixed resistor to set a reference voltage and a light-dependent resistor which changes that level that can be read by the analog pin of the AT-Mega 328P, in this case A0. This basic concept of changing voltage levels is essentially how the analog value of this project is inputted into the serial processing phase of this project. The next part of this circuit has to do with serial processing. Basically, code from Arduino's IDE software program is uploaded to the AT-Mega 328P through the use of a SparkFun Pocket programming device and a breadboard header to plug it into. It is easily able to write the code to memory and perform the same function again and again, which is why only a power source is required after the code is uploaded. Finally, the last part of this circuit is the digital output section. This section is simply made up of an LED bar graph that is wired to the digital outputs of the AT-Mega 328P and then wired to ground with a 330 ohm resistor network. It serves as a device to display the incoming analog input readings. All of the real development that actually allows the output section to display this analog reading, as it does, happens in the code, which tells the microprocessor what to output to the digital pins that it's connected to. The code used to execute this desired outcome of this project is compact and efficient, but also complex. Essentially what happens is that an analog reading of the pin that it is in between the LDR voltage divider and the analog input side is mapped or converted from the range of values it produces to a range of values that is exactly the number of LEDs on the bar graph. In doing this, the analog value can successfully be converted into a value that can be set to high or low on the bar graph. There's also an if statement, which this for statement is inside of, saying that if all the LEDs are on, make the bar graph blink to signify that it is at its max brightness according to the LDR. And that is how my version of the breadboarded AT-Mega 328P works. Thanks for watching.